Hello everyone, and welcome back to another video in our industrial warehouse design series, in which we are going to be talking about the design of the elements in this warehouse. Now before I start, I want to mention that I have not yet, and I am not intending to, model the purlins in those two surfaces, the front and back. I have not modeled them and do not intend to. Of course, I will leave this modeling for you. You have seen me model the other purlins and the claddings here, so you have enough experience and skill to do that. This is not what I'm gonna do. In this video, we're gonna be focusing on the design of the elements here. For the design of the steel connections in Autodesk Robot, I thought that I should be doing one full video where I design one portal frame only and show you how the different aspects of the connection design, because cramming everything in one video is kind of counterintuitive. So I will be doing a connection video, not on the full structure, at least on one of the portal frames, just to show you how it's done. And of course, you can implement everything in your integrated project. Please notice also that in this video, some of the processes are going to be iterative and time-consuming. When a process becomes iterative or time-consuming, I will be telling you that you should try different, for example, sections, and keep iterating until you reach a correct section. When it becomes iterative and time-consuming, I will save your time and tell you that this is something you can do yourself, because it would be a waste of time if I, for example, stay here for 1 hour trying different sections until one of them works. The principle I will show you, and then of course you have to embark on your journey on that. So I hope that you don't mind with this. With that being said, let's dive into the video. So sit back, relax, and enjoy the show. Okay, so of course we need to do some designing now, and to do the designing I need to have my load combinations and I need to have my section groups. If you go to the load combinations, I will go to loads, and in the design, please notice that you can design for fire. I am not including fire in my design, and if you're interested in the fire design, then I will link a video on the top right to see how you can include the aspects of fire in the design of your steel elements. I, however, will not do so in this video. So I'll go to loads, automatic combinations, and start creating my combinations. Of course, I have already prepared my preferences, as you can see in the video linked above in the first part of the warehouse design series, as well as the selection of the entire preferences can be shown in a video I will link above. So if you don't know how to change your codes, those two references are good for you to check out. With that being said, I will ask him to do full automatic combinations, and you can see you have a very large number of combinations here. Of course, you're asking, why is that so? It's that because the crane loads are incremental, and each, look at this. If you go to crane loads, for example, L, you can see that, I need to run the analysis, yes, but you know that when we defined our crane load, we defined it to be a point load that moves each 1 meter. And you have 40 meters of runway here and 40 meters of runway here. So of course you have a large number of combinations based on that. So I'll go to loads and automatic combination and ask it for full automatic combination. But that's not enough. I need to go to fire. I need to go to more. And if you go to more, I will here restrict myself to the SLS, because 6805 is too much of a burden. So I restrict myself to the SLS load combination, to the ULS load combinations, meaning that it's only the ultimate limit state. Before I do that, I want just to quick note for you. If you go to loads, if you go to analysis types, I had changed my crane loads into being an auxiliary case. I will remove that. So it's now a main case. Of course, you're asking, why have I changed my crane loads into auxiliary cases? I changed my crane loads into auxiliary case because I did not want to let him calculate all the 40 steps for every calculation I do in the structure, because I was doing preliminary runs. Now I've done my preliminary runs, so of course I need to change my crane loads from auxiliary to being main. Going back to load automatic combination, I want to have full automatic combinations and only the ULS, because I'm interested in the design today. Of course, you can check SLS and check the reflections. I don't want to do that in this video. And I can just click on generate, but I want to check out the relations here, and so on. If you go to groups, for example, here to understand, you can see that you have dead load, And in the dead load, the group, this is group number 1 for dead. And the only thing you see is dead load 1, that's normal. If you go to live, you can see that you have crane load L as being your first live load group. Second live load group is crane load R, and third live load group is live load 1. And there are no others. Of course, you have still wind groups, and you have snow groups, and so on. And in the relations, this is where things get interesting, because my groups are happening together. Like if you go to dead, you can see only one group. You can see some crazy stuff happening here because of the group sorting. How can I phrase that? Look at this. It says my live load case is going to be Q1 or excluding Q2 or including Q3. Now, if you go to help, you will understand those things. I don't like the relation that I see here. For me, my code group live load is going to have all of them together. You're going to have Q1 and Q2 and Q3. That's group case 1. You know what? I can create a group. Like, why should I do this? I can remove this, and I go to a group and create a group from cases. So for example, I can do an AND here. Oh, my computer froze on me. Okay, I can do an add statement here. Add this. Okay, that's really slow now. And add this. And add, can I do that? My computer is freezing now at the moment. That's not really a good sign. Let me just add this. Okay. And now I will just, well, create a group from the cases. And now I should have group cases 1, and those are the 3 cases. And they are ANDed because they happen together. Is that so? Let me check. Live, that's group case 1. Going up, my computer is freezing like really bad. Okay, I only have one group case now. It seems I deleted all the others, which is kind of cool. So if I go to relations, oh, see, it's better now. I can just basically add this, and that's my live load group because I ANDed them together. They all happen together. The crane happens in conjunction with the live load. So I hope this is now correct. Of course, we will see this later when we do. I mean, how can I see this? I can just click on generate. And when I click on generate, I go to ULS. And okay, I see a lot of things, so I think we are correct. I go here to the cases. Oh my, this is a lot. And let me select a case where I can see the live load. So, okay, let's see. He's taking, okay, look. He is taking 4, and he's taking 2 and 2. So he's taking 4, and he is taking 2. And is he taking 3? The equation is very long, right? Yeah, he's taking 3. Okay, he's taking, yes, that's good. Okay. So he's taking the crane loads as well as the live loads together, which is exactly what I want because they happen together. Of course, this is going to be a nightmare to calculate. I mean, let's click calculate and fingers crossed. Yeah, you see he's counting and counting and counting and counting. Oh my, is he going to have 6,800 cases? No, I think I reduced them, right? Now we're going to do this a lot and it will take a lot of time. So maybe if I find, okay, no, it's still manageable, I guess. So I have my ultimate limit state ready, which means my combinations are ready. And I just made sure that my Q1 and Q2 and Q3 are ANDed. They happen together because the crane load and the live load occur simultaneously. One comment of our dear subscriber, Donald Khani, mentioned that it should basically have a condition if it exists, and unfortunately, it doesn't. But he's saying that since you have a crane that is moving on the runway, the point load on the left and the point load on the right must be at like simultaneous, synchronous. Like for example, if the point load on the left is at this position, then the same position should be on the right. This doesn't exist in Robot, unfortunately. So this is once again the limitation of the software. But I get what he wants to say in this case. Okay, now we are ready in our analysis department. We now go to our design department. So of course I'm designing today only sections. So I go to design steel members. And of course now the fun starts because I need to create my groups. If I click on member verification and just click on calculation, this is not correct because I will only deal with ULS. And the thing that includes the ULS is actually case number 16. And it will take some time to design because I have so many cases. So let's click on calculation and you can see most of them are okay. Some of them are okay. Oh, that's cool. Some of them are okay. Some of them are failing. That's only a check, right? Okay, I mean, this is how we can verify, but I don't have any verification because I have not designed them yet. So I need to select, well, code group design, but you have no groups. Like if you click on list, there is no group. Why? Because I haven't created any groups. So I click on group, create me a new group, and call the group, I don't know, rafters, for example. Now the members in the rafters are going to be selected by the line selection tool, and this is the reason why we have done some placeholder sections, because now I can click IPE 400, double click, and all the rafters are selected. Now with this selection, I simply click here, one click, and the selection gets implemented. My steel is not carbon, my steel is S275 Eurocode. And my sections I will let him use to design are going to be the European code, the I sections. Now you have a lot of flanges. I will choose the IPE. The IPE might include the section that is adequate, or sometimes the section that is required for the rafter is even larger than what the IPE can provide. And in this case, you would have to expand your section selection. For now, I will choose the IPE. If it works, then I'm happy. If it doesn't work, then I will leave it for you to go and expand the section selection and let robot deal with the section selection himself. Now for me here, I'm done. I'll click OK, and that's my first group, so let's save it. I click New to enable a second group, and the second group here is called columns, or maybe portal columns. And I will delete all those sections here. I will delete all those lines here because my portal columns, I think, were IPE 550. So I need to select away and click IPE 550. So all my columns are selected. With them being selected, I click here and, well, I can save. But before I save, I should go to sections. They are the same as the beams, so I'm happy now. The only thing I need to do is click to save. I select a new group, and you can see where this is going. This is a repetitive task that I will do very quickly right now. So group number 3 is going to be called Gable stuff. I will just, because for the lack of time, I will just join everything that is regarding to Gable together. So IPE 300, everything, beams or columns, I don't care now. I will just join them together for Gable stuff. And sections, I will keep them as IPE. I'll save that. Okay, for this, I will call it purlins. The purlins are going to be, well, selected based on this line selection tool, and I think it was ZZEE or something. There we go, those are all my purlins selected. I click here to implement the selection. In the sections, I should have my ZCEE sections available here. So I don't want the purlins to be chosen from the IPE sections. I want the purlins to be chosen from my own sections, the user sections ZCE. We have created our section using a user-defined section. This is a cold formed section, although it's not yet being implemented as cold formed. I need to let robot know that, but we have not done that yet. I might even do this in the next video with the connections along that, and follow me with this. For now, robot sees this as being a hot rolled section, and I need to change that maybe in the next video with the connections together. I need to change it and deal with it as a cold formed section. So please keep this in mind. ZCE section today is being designed as a hot rolled section. So I just select ZCE. There is only one section, so that's fine with me. And basically, I'm not designing anything here. I'll save that. What else do I have? I have the bracings, and I have those tie beams, and the runway, and so on. Now you get the idea. You should keep doing groups. I will just do one other group just for sake of showing you the bracing. So I'll call it the bracings group. Notice that I have not grouped all the elements. You still have to group the tie beams, and I think I will do that. So purlins here very quickly. Those are the rond. No, wait, what? 5 is purlins, 6 is, okay, bracings. And let's just delete this and select the bracings by clicking on the line selection tool and clicking on rond 20. And I click here, and those are my bracings. The sections of the bracings are not going to be ZCE. They're going to be European section, round sections. Okay, and we have our group. Let's select a new group now. The new group here is going to be called miscellaneous, maybe, or tie beams, I guess. And the tie beams are going to have the sections that were, I think, rectangular, right? Double click here. First of all, deselect, double click here. Those are my rectangular sections, so I'm with the tie beams. Click here. The sections here, when he designs, I don't want him to design using round sections. I want him to design using rectangle sections. So T-rec. There you go. And let's save. And what else remains? The runway. Now, I mentioned before that the runway is not your job to design, depending on the location, of course. I believe that the runway is being provided by the crane manufacturer, so I will not create a group for that thing. With that being said, I will save. I'll go here and calculate code group design for all groups. So you can click all and hit the enter key. And now it's designing, and enjoy the show for now. And we can see our first failures. We can see that the rafters are failing. The columns are being designed. That's good. Gable stuff is being designed. Wait, why do I have two group gable stuff called? Did I mess up? I think I messed up. I think I have repetitive groups. Let's see. Rafter, column, gable, gable. Yeah, I think I have double groups. So of course, when you design, there are some members that totally failed. This, for example. And there are members that succeeded. Now, before I talk about failure and success and so on, it looks like you're done, but are you? Now, first of all, I have a warning here. The warning says that it's too thin. Of course it's too thin, because I did not tell him that it's cold formed. So he's basically saying that the wall thickness of the ZCE section is too thin to be considered. Yes, I know, and we will be talking about cold formed sections as well as connection design in the next video, which means I will start my reinforced concrete design series in the video after it, because it took me so much time here at the warehouse. Okay, and I don't want to cram multiple topics together in one video. I want my video to be concise and to the point. Okay, now, am I correct with this or not? I don't think I'm correct. I don't think I'm correct because, well, we have seen before that there's something called member types and properties. So, who did that? Okay, let me just double click here. EC Frame. I've explained this in a previous video. You know what? I'll just do this very quickly here. If you want more information, you can check out the video linked above. I will tell Robot to basically detect all the possible bracings automatically at points of adjoining elements. And that's it. Of course, wait a minute. You could call foul here and say lateral buckling for the lower flange should not happen, because we are assuming that the purlins are going to brace the top side of the rafter. And you're right. So I will not let it brace the lower buckling flange. I will only let it brace for general buckling and top buckling, because the bracing between the purlin and the rafter is only going to be targeting the top side, so I don't believe that the bottom side is braced. Okay? Still okay? Okay, I think there is a bug in Robot, right? Okay, let's please click again, okay. And there we go. Okay, now, you can, of course, have fire analysis and so on. I don't want to have fire analysis today. I'll save that. You can check out more. Yeah, okay. You can check out more details later. All right, so now I will apply this to my rafters. So I select here the section of the rafter. And I click here and apply. So that's my beam. If you go to column, similar things apply. Now here's the thing, are the purlins enough to brace the columns or not? It depends on your decision. I would say yes, just because I want to. But of course, if your purlins are too weak and not well connected to the column, then I don't think they will brace. Of course, that is something that you decide based on the sizing of your purlins versus column. It depends on you, to be honest. If you want it, you can enable it. If you don't want it, you can disable it. I'll save that and apply this to all my columns. So let's close. Click outside, select all the columns, and click here, apply. And now I have them all here. What about gable? I think the same thing applies here. I'm repeating myself at the moment. And now I will select my gable sections. So 300, I guess. Click here, apply, and close. And now I have everything. I'm ready. Let's calculate again. So he's designing now. I think the reason why it takes so much time is because now it's checking any intersections, and I think when he checks the intersection, he basically assumes bracing is here. Makes sense from a programming standpoint or point of view, so I think that is indeed correct. You can see him taking the most time with the rafters because it is the one that has the most connection intersections here. It says it's not safe. And why is it not safe, I might ask? Because of stability checks. Fine. Well, it means that he was unable to find any section of the IPE group, so you can, of course, choose another family. This is something I will leave for you. He tells you what the controlling load case is, which is ULS-3, which means it's the third component of the ULS. I should select the ULS here. The third component is what controlled the design, which is basically component number 3, which is this big abomination. You can, like all the cases inside. Of course, you need to change that or change the family to make it safe. What else do we have? He's still calculating because now he's intersecting bars, so of course it takes millions of years. While he is fighting for dear life here, I will go here and show you something very cool. If you click on change, he will change the section. If you click on forces, he shows you the internal forces based on the statics. If you go to detailed, I will leave it. This is really cool. If you go to calculation note, he will give you the calculation note of this section. If you go to parameters, you will see the parameters used. Oh my, I think my computer is exploding now. I think I overloaded my computer, to be honest. It tells you the parameters of that member type, ECB. And wait, what? Okay. And if you click on detailed, this is really spicy. He adds you can add stiffeners here at certain positions, and basically he's adding stiffeners at the positions. But how do you read this? You have a beam of 15.07 meters length, and he's adding stiffeners at the places where the purlins are being attached. This is really cool, and you can make an even more detailed check because the design of robot in this is a global design, just moment and global stability. But you can go into the details and perform a detailed check. You can check shear stability, web stability, stiffeners, and so on, and go really into details with all those little things that you can add and basically design that thing. Of course, the question here is, was the haunch included in the design? Was it or was it not? Well, robot did not see any haunch. So there is no haunch so far being defined on this structure. How do you define haunches? Well, so for now, let me just summarize what we have done. We have created our automatic combinations. We have created our groups. We checked our member types. We created the correct combination, and we designed. So what remains is you should click on change all and recalculate again. Now, before I do this, I'll go back to my structure because I want to show you something really very cool, how you can make haunches basically. So I will just do one to show you. So I click on geometry, additional attributes. There is something called brackets. And in the brackets here, you can define your haunch. I'll click here, new bracket, and I'll basically say here, my haunch. And you can add plates or sections. If you click on section, you can add full sections, like it's based on the section of the member. It says here the height is 1 of the section height, and the length is 0.1, 10% of the member length, and the position is down. So if you add this, you have a new haunch. And guess what? If you click here, it gets haunched. Now, can you see this? How do you see that? Okay, right click. I should be able to see it. I mean, I need to check this out in Robot Finds Data. But I mean, if you click here, a haunch gets applied. And I can basically, to make sure that I see it, I can click on the rafter beam here. Let me show you. That's my rafter beam. And I go to the properties, and you can see here in the bracket section that you have my haunch here. And of course, you can add the same my haunch there. I mean, you know what? I have an idea. I click selection tool. I think it will break robots because it's so complicated now. I click on IPE 400, so all my rafters are selected. I go to bracket and select my haunch here, and I go to bracket and select my haunch here. And now I'm guaranteed to have haunches at the two sides of the rafters. Will this change the design? I don't know. Let's run. Okay, so the analysis is complete. I'll just go to the design. And well, just click on calculations. Let's take a look what happens now. Of course, fingers crossed, it takes time. Okay, it seems that the design is taking ages, I guess. Okay, so the design seems to be completed. I go to results. The only thing that remains here is to check if you like the design and to change everything. If you click on change all the sections in the structure will be changed to the correct sections. Of course, now, after that, if you click on change all, it will change all the sections to the design sections. You can see them getting bigger here. And now you have to calculate again and do a verification again, because changing the section changes the internal form. Hey, look, there is the haunch. I was thinking why I can't see it. What's this? I have not changed anything. Okay, here is the haunch. That's cool. But the frame rate is down. As Josh in Let's Game It Out says, the frame rate is down. Fantastic. I think this is good. Oh, the brackets show only because of cross-section. That's cool. Okay, so I'm happy now. You should just recalculate and redesign, rinse and repeat until it converges to a section, because changing the section changes also the internal forces. What remains for next time is to design the connections and design the purlins using cold-formed steel sections. For now, this is hot-rolled steel sections. So I think the analysis is complete. I will save my file and I will continue next time. So before I finish, I want to give a huge CE-sized shout out to our dear channel members whose name are going to be shown on the screen, as their contribution to the channel is really priceless and helps us keep delivering and doing the thing we love to do. With that being said, I hope that you enjoyed the video and that it was beneficial for you. Of course, if you have enjoyed the video, then please like, share, comment, and subscribe, especially subscribing because it helps increase the reach of my channel. As per usual, this is the Civil Engineering Essentials channel, and we will catch you in the next video.